All right, I got to do this video under pressure. I just finished talking to you guys, so now I have to get video 3 done. We just finished up with nuclear chemistry. Okay, nuclear chemistry. Remember that you got new atoms forming when you do this, and this one happens to be alpha particle emission. And that's what these nuclear chemicals do. They, actually give off little particles. We set up one year where we could actually see the alpha particles coming off of the radioactive substance. It was really quite interesting. They leave a little trail through you have to make a real high humidity, and then as they travel through, they leave a little trail of water vapor. If you charge the thing, it's quite a difficult thing to set up, but we actually got it to work quite nicely, and it was very interesting. So that's what nuclear particles do. Some of them give off electrons, some of them give off just plain old energy like gamma radiation. But this is, and remember, all the top numbers or mass numbers have to be equal, and all the bottom numbers have to be equal. All right, here's a fun David Copperfield card trick. All right, there are 5 cards down there. I want you to pick one, and that's your card. All right, I'm sorry, of the 6 cards. And then we'll go to 5 cards. So there are 6 cards. You pick one. That is your card. Okay? And what we're going to do now is we're going to make your card disappear. All right? Everybody have your card in mind? Boom. Ready? Your card's gone. Thank you. Thank you. Unbelievable. I'm not going to tell you the secret. All right. Okay. Number 30 is talking about saturated versus unsaturated hydrocarbons. Those arrows were for me to draw these structures out for you, but I'm just going to give you the definition here for this problem, and that being a saturated hydrocarbon is just straight chain carbons with no double or triple bonds. It's saturated with hydrogens, okay? So there are no double or triple bonds on it. Make sure you get that written down. And unsaturated means it has at least one double or triple bond, meaning that you're going to have fewer hydrogens because you have to add those double and or triple bonds. And this question on the test just uses double bonds. And this is oftentimes used with fats, saturated fats versus unsaturated oils. These tend to be a little healthier for our body because the fats that are saturated and don't have any double bonds are kind of like that, and they sort of get clogged up and build up in the arteries, whereas if you throw in double bonds, then it kind of can be more of a liquid. So olive oil, which is unsaturated, is a little better for you than chewing on a chunk of lard or something like that. So again, saturated, all single. You can remember that, saturated single bonds. Unsaturated, at least one double bond, oftentimes more. Okay? So that'll help you with that. Number 31 is talking about a precipitate or a PPT. So here's a small little microvial. We did this with little drops looking for precipitates. Some of you got a chance to do that lab where we look at chemical reactions. But if you put the drops on there and it forms a cloudy substance, then you're like, oh yeah, there's a precipitate. that formed in that reaction. So what you can use to figure out if a precipitate forms is the back of your yellow sheet. All right, it has solubility rules, and I wrote on there for you which one is a precipitate, which is the column on the right side where it says insoluble compounds. That will form a precipitate or a PPT. All right, so use your yellow sheet. Make a note of that so that you can get quick reference to that, and then have that packet out and at the ready, and you can quickly get reference to that. Okay, so that is using that back of your yellow sheet will really help you with number 31. Okay, number 32 is a review of oxidation states. And this, you thought, I almost made it without having any significant homework. This one, I think, is worth looking up your oxidation rules either in your notes, if you've taken good notes all year. When we talked, right before we talked about batteries, and we talked about oxidation and redox and those kinds of things. But this is just assigning oxidation numbers. With a problem like this, you know that you have to have -2 left over. But I would strongly recommend looking up oxidation states either online or in your notes to review what the rules are for assigning oxidation numbers. So between these two, sulfur's kind of all over the place, but oxygen is always -2 unless it's a peroxide. Well, this is not a peroxide. I don't know if this particular one is, just going to check real quick here to see if this is not in the notes that I can see. It's not on your yellow sheet. Oh, no, there it is. Yeah. It's thiosulfate. Okay, this is thiosulfate. So it's definitely not peroxide because it's called thiosulfate. So what you can do is you can say, well, then oxygen is going to have a -2. And if you remember these problems, they're like nice little math problems where you go, okay, so I have 3 of these. That's going to be -6. So you can hopefully in your head figure out 2 of these at +2 gives you +4, -6, and that's a -2 left over. So that's oxidation rules and oxidation states. There are some very simple rules that you can go over. Hopefully you have some good notes that you can find that. Like I said, it was right when we were talking about electrochemistry and things along those lines. Oxidation, redox reactions. That is the very beginning of that, was assigning oxidation states. So a little bit of homework on that one if you want to help guarantee yourself getting the right answer. That is the end of our review. Good luck on the second portion of the test, numbers 17 through 32. We will take tomorrow during the class period. Okay, take care and do some preparation and organization for tomorrow.